I'm Derek Mallia, so I'm a research assistant professor here at the University of Utah's Department of Atmospheric Science. And so I study wildfires and how wildfires will impact air quality. And then in addition to that, I also focus on forecasting the impacts of wildfires. So that can involve the spread of the wildfire, but it could also include the forecasting of wildfire smoke, which is also of significant concern. And then when I talk about forecasting wildfire smoke, this could be forecasting the short-term exposure of wildfire smoke, so a few days out, or working on the more climate level length scales. So working with wildfires and projecting the kind of longer term impacts of how climate change might impact wildfires, and then smoke and smoke dispersion. So a big issue with wildfires is wildfires are relatively smaller scale relative to other phenomena in the atmosphere. And so because of that, it's relatively difficult to kind of simulate and forecast. And so a lot of forecasting frameworks out there assume that the fire activity day to day is unchanged, even though we know that that's not a great assumption. But to kind of do something better requires a lot better technology and computational resources, which we're getting to that point. And so I think a big area where we can kind of improve smoke forecasting, for example, is forecasting how the fire emission, so what's being injected off of the fire, how that changes day to day, and incorporating how changes in meteorology will relate to those changes in fire activity. So for example, if tomorrow is supposed to be hotter and drier, your forecast model will then inject more smoke into the atmosphere or produce more smoke because the fire is probably going to be growing a lot more. So those are some of the ways that we could probably improve smoke forecasting. Also, satellites are really offering a really nice opportunity to better detect fires and get a better sense of where the fires are located, what they're burning through. And so that kind of information can also help us improve our fire forecast. So remote sensing techniques such as satellites, I think, will also play a significant role in the future in terms of helping to improve forecasts of wildfires and wildfire smoke. Yeah, so our models simply just tell you what is the concentration of smoke. But an everyday person won't actually know what how dangerous that concentration of smoke could potentially be, or how unhealthy that concentration of smoke could be. And so what we could do is we could relate this to health information, or work with air quality managers and provide guidance of, okay, well, if the concentration of smoke is this value, you should take these precautions. So this is not just a weather forecasting issue, but this will also involve folks that are, more involved in the realm of, the health sciences and so on. I think a really fantastic model, granted it does kind of do the persistence assumption with smoke emissions, but I think it's still a very valuable tool, and then it's really the state-of-the-art kind of smoke forecasting model. But the high resolution rapid refresh model, HRRR, is the state-of-the-art kind of smoke forecasting system right now. And it really does a really good job with simulating smoke across the CONUS US and even North America to some degree. And so I think that's a really valuable tool for forecasting smoke. Granted, maybe the user interface that it's on isn't the most user-friendly for non-meteorologists, but nonetheless, it is a really good website and so on. I guess I would say is wildfires is very interdisciplinary. There's a lot of different aspects of wildfires that a fire researcher needs to consider. But what I would actually recommend is, as a student, just focus on one very small aspect of fires. Fires are very broad. There's a lot of things to consider. And so, I think you could very easily get lost in the weeds by trying to ask too big of a question. So I would actually encourage students to really focus on a very specific question related to maybe wildfire forecasting and smoke forecasting. Yeah, so I think wildfires has some of the strongest linkages to climate change, and it's one of those severe weather events that really shows a very clear linkage to climate change. And so I look at wildfires and better understanding wildfires and how climate might impact wildfires. That's the kind of forefront of climate science, and along those lines, it's a really important issue that really relative to other severe weather phenomena. It probably impacts actually the most people. Wildfires in themselves are relatively small, and the fires themselves maybe impact a much smaller population. Granted, wildfire smoke, that has the ability to impact, millions of people. And so along those lines, kind of encourage students to, yeah, this is a really important issue, and there's a lot of really awesome work that can be done in this space in regards to fires. And I think the research surrounding wildfires is really starting to take off, but in many ways it's really much in its infancy. And in terms of other severe weather phenomena, I would say there is still quite a bit of our lacking research in that area, and there's a lot of really interesting and cool work that can be done for the next generation of scientists.